Hello YouTube and welcome to Groundworks. Okay, this is the episode 3 of our RemoteTech guide. In the previous episode we have covered the map view, what each of the buttons does, what are the cones of coverage, what is the importance of the relay networks, and how is the signal being bounced back from the satellites back to the Kerbin Space Center. So we have also covered how to build a satellite that should be enough to cover Kerbin, Moon and Minmus. In today's episode, we will be showing on how to set up this relay network. And in front of me, I have a craft that I've already built. And let me just walk you through each of its components. The boosters and the parts of the craft that you see, including the fairings, are complements of KW rocketry. I will put the link to the mod in the video description. If we remove the main boosting stage, you will notice this is actually the old deployment craft. At the top you will see 3 of the communication satellites that I have shown you how to build in the previous episode. And at the bottom we have a deploying craft which will do most of the work. Now, you will notice here that I'm using a command pod instead of probe core, and this is simply because when you're launching initially the first satellites into the orbit, you may or may not have a direct communication with Kerbin Space Center, and in that case setting up the communication network can become very complicated and very tedious. So you want to have a Kerbin who will actually perform most of the dirty work, that is initial going up to the orbit, setting up the transfer orbit as we would like it to be, and prepping the communication satellites for deployment. And the communication satellites will do its final task, which means going to the exact orbit, deploying the dishes, and just staying there. So this is the craft that will be doing the lifting, and below it's the boosting stage. So this is the craft, and you can see it on the schematic that will be provided on top of this video. If you want to examine it in closer detail, you can either pause the video or you can, on a link to the image will be in the description. So now let's go and launch this one, shall we? Okay. So this is our rocket, and I have already proven that I'm one of the worst pilots in basically KSP history, so I'm not gonna have you watched through the whole process in one time, so I'll accelerate the launch. Okay, and let us now just prepare for circularization. Okay, so it is 100 by 100 roughly. And let us also extrude the solar panels so we don't forget it later. Now let us just time accelerate. We will need 141 delta V to circularize. Which means we can go pretty much down to the wire. Okay, that's good enough. That's close enough. So now that we have circularized, we'll also make additional burn somewhere here, and that should be the burn that would take us to our desired orbit for our satellites. So sort of like this-ish. And the apoapsis we want to set up to 1,500 kilometers roughly. Yeah, this is good enough. And that will take 504 meters per second, which is more than enough in our current stage. So now we are burning to extend our apoapsis to the desired 1,500 kilometers. Okay, so, and the craft deploying the satellites will remain in such an orbit. The reason why I did the burn on the dark side is so that we can continue to deploy our satellites at the apoapsis, which would be the sunny side. One also important thing to note is that we will want the Kerbin Space Center to be roughly here at the beginning, so once we start deploying our probes will immediately have a connection to the Kerbal Space Center. And this is actually most important for our first communication satellite. So let us just do the time acceleration until the Kerbin Space Center goes to the other side of the planet. To start with the preparations also zaboravi izreži. And we want to start preparing when we are roughly around here, so that we have some 10 minutes to orbit, so we have enough time to do everything basically. And to test if we are in range, let us just go and extend one of our antennas and see if we do maintain a connection to the Kerbal Space Center. Yes, we do, and that's great. So we will just put a maneuver node for the apoapsis here, and we will not execute it, but the point of this maneuver node is to tell us where to point our craft when we will be deploying the communication dish, when we'll be deploying the satellites. Sorry. So let us just turn to the maneuver prograde marker. Basically, deploying your first satellite is always tricky. You have to make sure that you are in the light side so that you don't run out of power. You have to make sure that your antennas or the Omni antenna is extruded and that it has connection to the Kerbal Space Center. Otherwise, you won't be able to steer your satellite. So we have pointed it correctly. Fine. Now I'm a little bit concerned if we will continue to maintain connection to the Kerbal Space Center, but looks like we will, which is good. Okay, and let us then start preparing for the satellite launch, shall we? So, first, make sure that the antenna is deployed for the satellite that you want to launch, and it is this one. Second, make sure that at least one of the solar panels is extended to ensure that your craft doesn't go out of juice. Fine, we have extended the panels, and typically what I like to do is I like to take the control from here and basically then just quickly do a decouple. It doesn't matter when do you actually decouple, because you will be more or less maintaining the same orbit that you initially had. The only thing to remember is now that we will put the maneuver node at the apoapsis to ensure that we set the desired orbit. And with the first satellite that you built, you want to have the orbit as close as you can get it to be. So this one is actually pretty good. 1499 with 1499. Fine. And let us then point prograde for that maneuver node. It's fine, and let us activate the engine. Fine. Now we are ready, and we are basically waiting until the time to apoapsis comes almost to 0 so that we can burn, because we want to be as precise as possible. So we can close down the alarm for the communication sat deployer, And while we are waiting, we could also rename the probe, because it's not really an interesting name, deployer probe. Let's just call it simply sat, shortcut for satellite, Kerbin to indicate around which planetary body it is, short range communication satellite 1. This is the marking system which I typically use, and it has proven very effective for me, especially when you have more satellites in the map view. So now let us just go close to the apoapsis. And I have also set up my Kerbal alarm clock. When I set up a maneuver node, it will immediately automatically populate it in the Kerbal alarm clock, so I don't forget it, which I tend to do pretty often. So fine, and let us now just decrease time to apoapsis, and around 15 seconds we will start the burn. Yeah, let's go. Okay, we have come close enough. Now we will do some final adjustments to get the orbit exactly as we want it to be. So let us do a little bit of time acceleration. That will also depend if we will have the connection to the Kerbal Space Center or not, which we currently don't, but we might in the next. No? Okay, then in the next pass we will probably have it here. Hopefully. Yes, we will. Great. So at periapsis we will just tweak our apoapsis and vice versa. It takes a little bit of fiddling, but you can get the orbit more or less exactly as you want it to be. So let's put it like this. And you will notice that for these fine adjustments I will actually be using the RCS. So at the periapsis we will be adjusting the apoapsis, making sure that it is roughly 1500 exact. So let us see. When the time to periapsis drops to almost 0, I will do a short burst to fix the apoapsis. Okay, 1500.2. That should be good enough. Now I'll disable the RCS and I will wait until I come to the apoapsis to raise my periapsis. Note that I am also watching my time to apoapsis so that I'm as close as possible to 0, because then I can adjust my periapsis without too much affecting my apoapsis. Okay, 1502 and 1503. This is as close I'm gonna get it, so I might as well shut down my engine so I don't accidentally activate it, and let us turn this into a real communication satellite now. So the first we will activate our communication dishes. The Omni antenna is already active and it will be able to communicate with any craft around. And the communication dishes, the first one will be pointing to active vessel and activate. The main point of this antenna is to cover transfers. So transfer from, for example, Kerbin to Moon, Kerbin to Minmus, or to some other planets. So it will be pointing towards the active vessel. The second antenna I want to be pointing to the Moon. So target Moon, activate. And the third one will be pointing towards Minmus. That's it. So with these three antennas, I'm basically, or four if you count the Omni, I'm covering the whole Kerbin system. So if we turn out now the cones of coverage, you can see the antenna, one of the antennas is pointed towards Moon, and every craft in its orbit will be able to pick up the signal, and another one is pointing to Minmus and all the craft around it. So this is actually, with the 3 satellites deployed in Kerbin Orbit, you will have a redundancy, so wherever you go, you will maintain a constant connection to the Kerbal Space Center. So, one final thing that I want to do is to extend the other panels, although they might be unnecessary. I found that it's good to have a few more, just in case you get a bad angle towards the sun or something, and in that case extra panels do help. Final thing that I will actually do is point my craft towards the sun to ensure best possible coverage. And that's good enough. Fine. So, this is how you deploy your first satellite. The second and the third is basically rinse and repeat. So, now let us see where our communication satellite deployer is. Switch to. And now we will do a couple of orbits around. What we want to do is basically to deploy, ideally, our satellite at the apoapsis, the satellite number 2, when the first satellite would be either here or here, so that they are being deployed in a triangle fashion. So let us see. This doesn't need to be a requirement, because then you can fiddle with the orbits to have it fixed later. So it's not really a big deal if you don't. Yeah, I think I will deploy mine now, because I am maintaining a visibility to the Kerbal Space Center, which I found to be more valuable, as it is quite easy to fix the orbits. I'll show you how to do that. So that's one. And extend the panel. Note that if I didn't activate this antenna, at the moment when I would be decoupling from the main craft, my satellite would become a dead stick, and I would either need to go with a Kerbal on the EVA to fix it, or I would basically need to fly another craft and try and fix it anyway. So let us now decouple. Oh, first we said control from here. And now decouple. Fine, and since this satellite hasn't exactly reached its position that I would like it to reach, I will probably put my orbit a little bit higher than this one to make sure that the orbit of my second satellite is a little bit slower, which would give them on the next turn chance this satellite to reach this point. So if you want to be really conservative on the fuel, you might want to wait a couple of orbits or just do another circle, but I found since I'm maintaining connection to the KSP, to me it's much more valuable than anything else at the moment. So let us just do, and so I know basically that when you are doing an orbit at 1,500 kilometers, that your orbital period is roughly 2 hours and 49 minutes. So if we say that it's 1 hour 49 minutes, then half of the circle is 1 hour and 25 minutes. So if we want a third of the half circle, that would be 1 hour 25 minutes divided by 3, so that would be 85 divided by 3. So it would be around 30, let's say 20, let's say 28 minutes, 29 minutes. So what I'm counting here, I want my orbit to be 28 minutes longer than the orbit of this satellite to make sure that it will pass 1/3 onwards. So it might be a little bit confusing, but I'll show you what I mean in a very short time. And now we want to accelerate that we come as close to the apoapsis as possible once again. Yes, thank you for the reminder, Kerbin alarm clock. Notice that the second time, as opposed to the apoapsis and periapsis, I'm looking at the orbital period. And I almost forgot to activate my engine, which would be rather embarrassing. So now let us do the burn. So if we say it's 2 hours 50 minutes, it would be 3 hours and 20 minutes roughly. Something like this. Let us see. Yes, it's significantly higher. And let us see how it will look like once we do a full orbit. If my calculations are correct, when we are at the periapsis, this one should be exactly here. And yes, it will be more or less perfect. So So now we will want to first slow the time acceleration and then reduce our orbit, because this is ultimately something we want to keep. So let me just quickly turn around. We're coming close to the, let's say, 10-second mark. Okay, and let us now do the burn. Two hours, 49 minutes, and let's say somewhere around 33 seconds. We'll do a quick check of this. I will disable the main engine, and let us just quickly now go to the first satellite to see what is its orbital period, because you want to match those as closely as possible. So it's 2 hours, 49 minutes and 36.581 seconds. Note this very carefully, because this is the value that you want other satellites to match. And it is very important to get this as close as possible, because when you will be running multiple missions, your satellites will drift a little bit. And the lower the difference in the orbital period is, the less drift there will be between your satellites. So now let us see, we are pointed retrograde, fine, and let us just fiddle with the RCS until we get exact matching period. So 49.31, we need 36.581. 36. Okay, 36.34. This is, I think, as close as I can get it. So if you want to have it exactly right, you might want to use maybe some tool like HyperEdit or something. But I find it to be a little bit cheaty, and as you can see, deploying second satellite is much easier because you can already bounce the signal off the first one. So this is the reason we are maintaining connection even though the Kerbal Space Center is on the other side of the planet. So let us then redo our communication dishes. We said active vessel, deploy, moon, deploy, and Minmus, deploy. Then we deploy the solar panels, rename the satellite, satellite Kerbin short range CommSat 2. Fine, and final step, point it towards the sun. This is not really a necessary step, but I found that it pays off actually. So that your solar panels get maximum possible exposure. Yeah, that's the second one fixed, and now onwards to the third one. dataset preparation, activating the antenna, extending the solar panels, and wait for a few orbits until these two satellites come at a favorable position. So what you want is basically one of them to come here and another one to come here, so that it is sort of like equilateral triangle. So let's see. This is one aspect of the RemoteTech that I really like. You can see how your active connection is being bounced off the relays and as you go around Kerbin, which I found really cool. And seems like on this orbit we would actually be able to deploy, with minor tweaks later. Looks good enough anyway. Okay. I think we are pointed in the slightly wrong direction, so I will just take the opportunity to actually turn the craft around. And given that it has such big rocket, it has the agility of a bus. We have some 12 more minutes to the apoapsis, so we have plenty of time. And we don't have to be really exact with the pointing, so let us just go and accelerate time a bit more until we get closer. Okay. Now let us do control from here, decouple, add a maneuver node, and since this satellite we want to come somewhere around here, meaning we want it to travel shorter orbit, so it actually goes faster than the other two satellites, and my rough estimate we want it by 1/3. So again, 28 minutes shorter. So if it's our current orbital period is 249, we want this period to be 221 roughly. So we won't be following this maneuver node anyway, it's just to give us some direction where to point the craft when we come at the apoapsis. So let's see. And let us activate the engine. Okay, and now we're waiting just to the apoapsis. Thank you for the reminder. And more or less we can start burning in, let's say, 5 more seconds. 2, 1, let's go. We are now watching our orbital period, and we want it to become 2 hours and 21 minutes roughly. Okay, And now, assuming that I have calculated my trajectory correctly, in the next orbit, when we go one circle around Kerbin, we should be here when the two other craft are here and here. So let us see. Yes, and this is more or less as we would like it to be. It's not 100% ideal, but you can fiddle a little bit around if you want to. I just think that once you can set it out as you like it. Let's go down to the apoapsis. Oops, and point prograde. And make sure that we do the burn to more or less match the orbital period. (49.36) is what we need to match, so okay, there it is, 2:49.36. I will now disable, shut down the engine, shut down RCS, and as you can see, this is not exactly equilateral triangle, but it's close enough. And it will not drift as much as assuming that these periods match more or less exactly. So final things to do is activate the dishes, active vessel, activate, moon, activate, and Minmus, activate. So communication dishes are done, extending panels, and renaming the vessel. So sat Kerbin SR CommSat 3. Fine, and final step is point towards the sun. That's good enough. Okay guys, so now if you take a look, we have our communication network deployed, and that communication network is covering, if I enable the communication dishes, is covering Moon with 3 antennas from 3 different satellites, and Minmus, same thing. So this has pretty much been it for this tutorial. Now the only thing left remaining is to safely return Jeb to his home, but this is not something that I will be showing in this tutorial. If you have liked the video, please do like the video, and if you want to subscribe, do so. It helps me out a great deal. In the next episode, I will be showing the design philosophy for making long-range satellites that will help you with the transfer between Kerbin and all other planets while maintaining a constant connection to the Kerbin Space Center. Those satellites will be leveraging of this communication network that we have set up, and they will only be targeting the active vessel. So thanks again for watching. This is GroundForks signing off.